Number 21 on the review packet. Describe the transformation or sequence of transformation that map this figure onto that one. So first thing I look at is, okay, it's an enlargement, right? Because the image G prime, G, or should I say G prime, F prime, E prime, that's bigger than the pre-image. Okay, so it's an enlargement. So scale factor is going to be greater than 1. So these are things that I keep in mind. I write it down now so that I, can remember later. What I'm going to look for is maybe, I don't know, how much bigger is it? Okay, and I can also look at, yeah, let's draw this too. What we know, let's find the center. Okay, so the center is somewhere located on the line connecting G and G prime. The line connecting G to G prime contains the center somewhere. So it looks like I'm going, let's see, yeah, this slope, keep going over 2 left 1. All right. Somewhere on this line is the center. It's looking like it's going to be right there. Let's find out. Okay, yep, right there. And then, so what I did was, I also did E to E prime, also contains the center. So wherever they crossed is the center of dilation, right there. So the center, we use this as 1, 2, 3, 1, 2, if it is, in fact, only a dilation. It's the center's at 3, 2. If there's any translation involved, then I didn't do it right. So let's find out. Maybe I'll check this last one. Let's see, does that meet there? Yeah. So it looks like I'm going to be okay. Let's just check the scale factor. Now, from the, say, center out to G, from the center to G, the change in X is 2. Okay? Center to G prime, the change in X is 1, 2, 3, 4, 5, 6. Okay, so now one of the things I do for scale factor is I say it's image over pre-image, and that's assuming you're going to take care of distance from the center to the image. So the image is 6, the pre-image is 2, so that's giving me a scale factor of 3 and a center of 3, 2. So what we did was we dilate triangle EFG centered at the point 32 by a scale factor of 3. That's fully describing it. Just saying it's a dilation is not describing it fully. So that's what we need to do on that one. For this one, it doesn't look as nice, so I think what I'm going to do is I'm going to dilate using the center at the origin first to get the size right, and then I'll just translate after that. So what I'm going to do is I'm going to dilate triangle ABC centered at the origin. By a scale factor of, now I'm going to have to take some work to do this. So one of the things I'm going to look at is how far is it from A to C? I've got in the change in Y, right, it's 4. Now A prime to C prime, the change in Y is 2. So again, let's look at that scale factor calculation. The scale factor K should be the image over the pre-image. Now the image is smaller, it's 2, the pre-image is 4, so our scale factor, if we reduce it, is 1/2. So we're going to scale factor 1/2. Okay, now let's actually go perform that though from this center. So the distance, the change in X right, for this is 2. Change in y is 1. Cut that in half. We're going to go 1.5. 1 in the x direction, a half in the y direction. That's going to be c prime. Not great, but we'll just have to do it this way. There's probably a better way, but this is just the way I decided to do it. Same thing with b. It's 1, 2, 3, 4 to the right, and 1 up. Okay, change in x is 4. Change in x is 4 times a half. Okay, change in y is 1. For b prime, the change in y should be 1 times a half. All right, so that is going to be right there. B prime, a, it's 1, 2, 1, 2, 3, 4, 5. And I'm just doing some calculation here. The change in y, I said, was 5, right? So change in y for a prime is going to be 5 times a half, so 2.5. Okay. So I'm going to go 1 in the x direction from the center, 1, 2.5. So that's where it would land. Okay, that's a prime. So centered at the origin, go back to this, dilate, center of the origin, scale factor a half. That's not great, but it's what I got to do. All right, that's going to be move number 1. Move number 2, I'm going to translate triangle A prime, B prime, C prime. Let's see, we're going to go, let's match, ooh, I should have called it something else. Let's just fix this to being double prime. Translate triangle A prime, B prime, C prime. So we're going to go 1, 2, 3 to the right, or 3 to the left. So left 3, up a half, 1.5. To map onto triangle A double prime, B double prime, C double prime. So that's what we're going to do. And is there anything else we have to do? Yep. So we mapped triangle ABC onto triangle A prime, B prime, C prime. There's probably lots of better ways, but that's what I decided to do there. Okay. Moving on to a proof. So, all right. So what we're going to do is we're going to try to prove that the triangles are similar. And then we'll show this is going to be corresponding sides of similar triangles are proportional. So the triangles that we're going to get similar, we're going to use angle, angle, triangle similarity postulate. Okay, so what we have is a right angle at E and at B. Then what we're going to have is a reflexive angle here at C. So that's going to get us our angle, angle. So I'll go through that. So step 1 in this proof, remember I'm after the right angles being congruent. So what I want to say is I need to use this perpendicular. Now this is true because it is given. Now the move I'm going to make is I'm going to say angle B and angle CED are right angles because perpendicular segments form right angles. All right, so now I've got right angles. Let's make them congruent because we do want angle, angle. So angle B is now congruent to angle CED. That's because all right angles are congruent. All right, that's our first move. Now angle C is going to be congruent to itself by reflexive property. And now the triangles are kind of similar. Now we got to be careful. Let's go with ABC, triangle ABC. It's going to be similar, not congruent, but similar to triangle. Now we got to get the matches correct. I'm going to go D, right, and then E, because E has the right angle, so does B. C, of course, if you look, C has to go there, so that they're corresponding. Okay, so those are similar, and that's by the angle triangle similarity postulate. Now, we won't do this on the first test, but we will have to do one like this afterwards. I'm just going to finish this proof off. The test that we're going to take on Thursday, as your Thursday, it's going to be, we're going to stop right here, but there's one more step to this. What we have is corresponding sides of similar triangles are proportional. So if you look, CD, third then first letter, is to CA as DE is to AB. And that's because corresponding sides, the key word here is corresponding. Corresponding sides of similar triangles are proportional. Don't say the word similar here. Okay. Proportional is the word there, or same ratio, have the same ratio. Okay, that's it for this video. Finish up in another.